Okay, page 14, example 4, we need to construct a trapezium ABCD. And this question says that AB is parallel to DC, which means the trapezium should looks maybe this way or this way, and any other way whereby the line CD and AB are parallel. So we will now do a rough sketch with AB is 11.4 cm, and next we know BC is 4.4 cm. So BC could be here, here, or here. But which choice should we choose? The question tells us that angle ABC is an acute angle. So acute angle is less than 90 degrees, so we should choose the first one. Okay, next part, you are asked to draw AD is 4.4 cm and angle BAD is 75 degrees. So we know that this is how the diagram looks like before we start. So now we shall begin with the question. So first of all, let's start with drawing AB again. AB is 11.4 cm. So A, but because AB is a length, so we must always remember to measure with a compass 11.4 cm. Okay, 11.4 cm, and you draw an arc. Okay, let's counter check. This is point B and it's 11.4 cm. Next, BC is 4.4 cm. So let's measure. .4 cm. So, and because BC is ABC is an acute angle, as we said just now, and when we were doing the sketch, it should looks, this the arc should be on the left hand side. Next part, AD is AD is also 4.4 cm. So we go to point A, draw the arc. Next, we measure at BAD 75 degree. This is 70. .75 Okay, so we will extend and check, mark across where the arc and the line cuts. This should be the point D. So the next thing we will do is, where should we mark the point C? As we are not sure about the angle at ABC, but we know that this is a parallelogram. So we will actually place the ruler along AB. And the other ruler will place side by side to ensure that there's a 90 degree here. Okay, at this corner. So when we slide the ruler along AB with against this the other ruler, the vertical ruler, we can actually draw parallel line. And this is the point C. So this AB should be parallel to CD. And next, you connect them together. So next part B. We are asked to measure the length of CD. So we notice CD is approximately 8.9 centimeter. And next, for this is part B, sorry. Okay, this is part A, part B. Part C, you are asked to measure angle ABC. So we notice that ABC is approximately maybe around 74.5 degree. Okay, it's approximately upon 74.5 degree. Next, we will measure angle BCD. Okay, when we go to angle BCD, we notice that angle BCD is approximately 105.5. If AB and CD are parallel lines, it is indeed true that angle ABC is, as you can see from the measurement, is 74.5, and angle BCD is 105.5, and the two angles would add up to be 180 degree. It is certified that the two pair of parallel lines are indeed accurate in the drawing. That's why we can get 180 degree. Okay, so this is a check. Let's check, since the question also tells us to find angle ADC. So if you place it at angle, this is given as we have measured to be 75. Let's check what is angle ADC. Okay, and you can see it's actually 105 degree. So this is an accurate construction. Next step, in D, you are asked to construct the perpendicular bisector of BC. So, as we know, perpendicular bisector means cutting the line segment BC exactly into two equal halves. So we will first go to the point B, ensure that the compass is more than half of the length BC. We will draw an arc on top of the line BC, somewhere in the middle and not around here, because we want the arc to later draw a line cutting the segment, or the line segment BC. So it should be somewhere here and here. Next, we move the same compass to the other point C without changing the length of the compass, and we draw the arc cutting the other two arcs. So we will next connect the two lines, the two points where the arcs meet, and this is D part 1. We can further certify that BC is actually cut into half by this perpendicular bisector by checking that the distance from C to the middle point here is actually 2.2 cm, and the distance from the middle where the line perpendicular bisector cuts the line segment BC to point B is also 2.2 cm, to ensure that this is an accurate bisector. Okay, next step. D part 2. Construct the angle bisector of ABC. So we will go to the angle B. Okay, instead of so we will maybe shift the compass so that it won't interfere with the first drawing which I did just now for the perpendicular bisector, and make it smaller so that it won't interfere with the first bisector. So we will draw here an arc on the length of the line AB, as this is the line segment which makes up the angle ABC. Then we will actually also draw another arc on the line BC which make up the angle of the angle ABC. So basically you have to draw on the two lines which makes up the angle ABC. Next we will move to this, the intersection point of the arc with the line AB, to draw an arc from here. So this is equidistant, and next we also move to the point here to draw another arc. So the point where they cut, I will connect to the angle ABC right in the middle, and this is the angle bisector of A, B and C. In fact, similarly to the perpendicular bisector, you can also use your your protractor to measure that the two angles which are divided are actually equal. Okay, as we have found just now that angle ABC is 74.5. So each angle here should be approximately 37 degrees. Okay, it's approximately 37.5 to 37.25 degree, 37 degree, and this is also 37 degree. Okay, so this is something that you can do to counter check. Last part is part E. You need to mark the point T where the two bisector meets. So D part 1 is here and this is D part 2. So where is the point T where the two bisector meet? It's simply at this particular point. So you need to mark it and label T. Remember, mark it and label T. Next, you measure the length of DT, which is approximately 8.4 centimeter. So part E, DT is 8.4 centimeter. Okay, that's all.